Let's dive deeper into the fundamental components of any GNU Radio Companion flow graph: sources and sinks. These are the entry and exit point of your program, where the data flows into and out of the system, creating the backbone of your signal processing pipeline. Source blocks are where your flow graph begins. They introduce streams of data that will be processed as they travel through the connected blocks. Think back to the analog to digital examples we discussed earlier. Remember how a sequence of numbers streamed from the analog to digital converter? Yeah. Source blocks work similarly, injecting streams of data into your flow graph. One of the most essential types of source blocks is the SDR source, which pulls data directly from your software-defined radio hardware. This block lets you work with real-world radio signals. But don't worry, this comes later in your journey. For now, we will stick to the source blocks that don't require any hardware, making it easier to learn basics. There are some key source blocks you will encounter in your journey. The first is file source. File source. This block retrieves its data from a file on your computer. For example, in this course, we have prepared a data file that mimics the behavior of real SDR hardware. You will use these files to practice streaming data into your flow graphs, building foundational skills without needing any specialized equipment. We also have a signal source block. As the name suggests, this block generates synthetic signals, including pure sinusoids. You will use it to create test signals for your flow graphs. These signals are invaluable for learning how different processing techniques affect the data. Constant source block. This is the simplest source of all. It creates a stream of identical numbers. While it might sound basic, you'll soon see how useful this block can be in certain situations, such as testing or initializing a flow graph. Just as sources bring data into your flow graph, sync blocks handle the output. Data flows through your flow graph, gets processed, and then exits through a sync block. Sync block define how your processed data is utilized, whether it is saved, visualized, or sent to hardware for further use. Similar to source blocks, some sync blocks interact with the hardware, like this SDR sync, which transmits radio signals. However, many sync blocks don't require special hardware, making them perfect for your early experiments. There are some sync blocks you will frequently use. The first is audio sync. This audio sync, this block routes data to your computer's sound card, letting you listen to processed output as audio. Whether you are tuning a radio signal or experimenting with signal modulation, hearing the result can be incredibly informative. You might also need to save the output for your analysis later, which the file sync block captures processed data and stores it in a file in your computer, ensuring you have a record of your flow graphs output. And we also have the instrumentation blocks. There are special type of sync block that don't have a direct counterparts among source blocks. Instead of sending data to hardware or files, they visualize the data in real time. For example, you can use a graphical display or observe waveforms, spectra, or other metrics as your flow graph runs. This immediate feedback is invaluable for debugging and fine-tuning your programs. That's it with our lecture. In your first flow graph, you will use both sources and sinks to see how data flows from input to output. As you gain experience, you will begin interacting more advanced blocks, including tools that interact with SDR hardware. But for now, focus on mastering the basics using simple source and sink blocks to process and analyze data. Sources and sinks may seem straightforward, but they are the cornerstones of every flow graph you will build. By understanding their roles, you are setting a strong foundation for tackling more complex signal processing tasks. Next up, we will walk you through creating your very first flow graph, complete with instrumentation blocks as the output. Let's get started.